Thank you. It's good to be here today. Samuel, I'm not. I don't know exactly what you said when you were introducing me. Only good things. That's good. So I'm the final speaker today. I'm going to talk about not all ruminant encapsulates are created equal. Oops. Samuel did a nice job explaining Balchem at the beginning. The only comment I'll make here is that, again, our company was founded in 1967. So the company's 57 years old. And I always say we're basic in two things. We're the world's largest manufacturer of choline chloride, and that choline and that business goes throughout our different business units. We're also basic in microencapsulation technology. We've been encapsulating products since 1967. That was one of our core businesses when we started the company. So we are experts in the microencapsulation business. So there are a lot of applications for encapsulates throughout the company. Most of the applications are in our human nutrition and health business. These are just some different examples. So we encapsulate products for baking applications. We encapsulate flavors that are used in confections and in coffees and products like that. And we encapsulate products that help with shelf life preservation for meats and other products. The last time I asked this question internally, as a company, we sell over 200 different encapsulated products that are used in various industries. Most of those products are actually used in the human parts of our business. For our animal businesses, we sell a lot of encapsulates. So from monogastric species, we encapsulate tannins. We encapsulate acids that are used in the monogastric species. And then about 7 years ago, we started a companion animal business where we encapsulate products that are used to manufacture dog and cat foods. So we encapsulate some acidulants that are used to make pet treats and other products. And we encapsulate products that are used in structure and forming technologies in the pet industry. Ruminant encapsulates, of course, our flagship product would be ReaShure. The new generation is ReaShure XC. The ReaShure franchise has been around since 1999. It was our first entry. It was Balchem's first entry into the animal space. We were not active in animal nutrition until we introduced ReaShure in 1999. And ReaShure, or the new version, ReaShure XC, is encapsulated choline chloride. NiaShure is encapsulated niacin. AminoShure XM is rumen-protected methionine. AminoShure L is rumen-protected lysine. We were the first to market with a rumen-protected lysine product that was introduced in 2008. And we also have an encapsulated urea product called NitroShure. NitroShure is different from the other ruminant encapsulates. when we're protecting choline or niacin or amino acids, we're trying to bypass the rumen. We're encapsulating to protect those nutrients from ruminal degradation. NitroSure is a slightly different concept. We want the urea in NitroSure to be degraded in the rumen just slowly over time. We're trying to slow down the ruminal release of urea with that product. So there was an article published in a U.S. feed industry magazine called Feedstuffs. This article was published in 2011, and so one of the quotes from that article was, "Not all encapsulated products are created equally. Consequently, there are vast differences in their efficacy and stability," and that is definitely a very true statement. And that's what I intend to show you during my presentation is some of these differences between products. So encapsulation it's a very generic term. There are vast differences in products that are protecting the same compound even. So what is some of that variation coming from? One difference is the starting form and the mode of inclusion of those nutrients in the encapsulate. The coating and composition of coatings can vary dramatically between products. And the actual manufacturing process to make these encapsulates can vary dramatically. So again, one of our core businesses is microencapsulation, and essentially what we are doing when we produce our encapsulates, we have a core of nutrients that we are protecting, and we fully envelop it in layers of lipids. It's lipid-based technology. In the animal feed industry, essentially all encapsulates it's all lipid-based technology. This is a micrograph of one of our encapsulates. So you can see here, there's the active compound in the middle that we're protecting, and you can see the lipid coating on the exterior of the product. So again, encapsulates can differ in product design. The technology can differ, and from a performance standpoint, there are some major differences here. There are big differences in feed and TMR stability, and differences in animal performance, which I will show you. So again, differences are due to starting form and inclusion rate of the nutrients. So for example, if we were to take rumen-protected methionine products that are on the market, the methionine content, and I'll refer to the nutrient content as payload of the product. So the methionine content of various products on the market, there are products as low as 33% methionine and as high as 85% methionine. So the payload or the nutrient level can vary dramatically between products. The coating systems that are utilized vary, and there are very large differences in composition of the coatings between products. For the ruminant encapsulates that we make, the coatings, the actual composition of the coatings varies. There's a lot of science behind creating these products, and there's a lot of art. But essentially, we're designing through these coatings the optimal nutrient delivery to the animal. And the manufacturing processes can vary. So there are a lot of different technologies that can be used to encapsulate nutrients. In the pharmaceutical industry, there's a lot of encapsulation that's used there. So some of the different technologies that are used, it could be a single coating technology, multiple coating technology. Some of these products have very irregular shapes. There's a matrix technology that I'll discuss a little bit more. Some of these products may have multiple active compounds in them, and there's another technology known as plated liquid. But when it comes to agricultural applications, there really are two different types of encapsulation technology that are used. But you can see from this picture that these are all ruminant encapsulates here. These are not all Balchem products. Some of these are our products, some are competitive products. But you can see that both the shape and the size varies a lot between these products. So these are the two basic types of encapsulation that are used in the animal feed industry. Again, they're all essentially lipid-based chemistry that's used in encapsulation. So the technology on the left we refer to as matrix encapsulation. It's also known as spray cooled or spray chilled encapsulation. The analogy that we use here is it's like making chocolate chip cookie dough. So let's say we're trying to encapsulate choline chloride in this case in lipids. So essentially what you're doing to create a matrix encapsulate is you're mixing the choline chloride particles with lipids and you're forming particles. So this would be what the particle would look like. With a matrix encapsulation, some of the nutrient that you're trying to protect is at the surface of the particle. So these particles that are at the surface are very susceptible to ruminal degradation. So in general, matrix encapsulates have lower levels of ruminal stability. So reduced protection and reduced stability in general with matrix encapsulates. The right-hand side of the screen shows what we refer to as a true encapsulate. All of our ruminant products that we make, all of our ruminant encapsulates are made with true encapsulation technology. So there's no compound at the surface. So what we're doing is, when we're protecting choline chloride, we have a core of choline chloride that we're protecting, and we completely envelop it in layers of lipids to form a true encapsulate. In general, true encapsulate products have higher levels of protection and higher levels of ruminal stability. So this is a time-lapse picture that was taken. So this is comparing a true encapsulate. These are lysine products. So there's a true encapsulate here versus a matrix encapsulate. These two products were placed into room temperature water in flasks. So in each of these pictures, the left-hand flask contains the true encapsulate. The right-hand flask has a matrix encapsulate. This is at time 0. So immediately when they're put into water, you can see some difference between the two products. This is after 30 minutes in water, And you can start to see some color difference in the water. This greenish color that's developing in the water, that's the release of the lysine hydrochloride into the water. So after 30 minutes, you can see there's a difference between these two products. After 2 hours, there's a very large difference. And after 4 hours, there's a huge difference between the two products. So the matrix encapsulate is losing a lot of the lysine to the water. This is certainly not nearly as harsh of an environment as what's happening in the rumen of the cow. With the constant churning and mixing of materials in the rumen, as well as a different pH in the rumen, it would be an even more dramatic difference in the rumen. And I'll show you some examples of that here in a few slides. Another attribute of a good encapsulate is that they're freeze-thaw stable. They can withstand freezing and thawing. All of our encapsulates are freeze-thaw stable. Part of that is because of all of the human food applications that we have for our encapsulates. We have a lot of products that are used in baking applications. They have to be able to withstand freezing and thawing. So both of these products that I'm showing here, these are not freeze-thaw stable products. So we occasionally test competitive products that are not freeze-thaw stable. There are some of those that are out there. So if we look at the top pictures here, these are two different encapsulates before freezing. The bottom pictures are after freezing, and you can see in both of these products there are cracks or fissures that are forming as they go through a freeze-thaw cycle. That will reduce the efficacy of the product. It's going to reduce ruminal stability. And so this is a graph. The blue bars on the left would be a that would be a freeze-thaw stable encapsulate. So prior to freezing, the ruminal stability is 90%. After freezing, it's still 90% rumen stable. The green bars on the right would be an encapsulate that's not freeze-thaw stable. So prior to freezing, that particular product was about 80% rumen stable. After freezing, it's only 40% rumen stable. So it's losing half of the ruminal stability just by going through a freeze-thaw cycle. This is an example of a product that's not freeze-thaw stable again. So on the left is our NitroSure product, the encapsulated urea product. These pictures were taken under a microscope with a dye added. So the NitroSure you can see is still, so both these products are white in color to start with. So the NitroSure does not take up any of the dye. It's not absorbing the dye. The product on the right is a competitive product. It's not freeze-thaw stable, and you can see some of these cracks or the fissures in the coating. If these products absorb the dye, that means that they're damaged. So that would be a damaged product on the right. Would not be very stable at all in the rumen. And of course, the reason why we encapsulate nutrients for ruminants in general is, we're trying to protect those compounds from ruminal degradation. Choline's 98 to 99% degraded in the rumen. There's a lot of good research showing that from years ago. So the rumen microbes love choline. They love to chew it up. Niacin's about 95% degraded in the rumen. The amino acids are highly degraded in the rumen as well, generally about 90% degraded in the rumen. my cow showed up, unlike some of the other slides. Now, hopefully all my other things will show up as well. So, when we are developing new products for ruminants, or we're improving existing products, there are a lot of steps we go through in the product development process. So the first step we look at when we develop a new encapsulate is we want good ruminal stability of the product. So we want most of that compound to make it through the rumen intact. If a product does not have good ruminal stability, I always say you sort of lose the game from the start. If you're losing most of the compound in the rumen, it sort of defeats the purpose of encapsulating it in the first place. So it's a balance between these different parameters. So we want good ruminal stability to start with, but we're trying to do that with as much intestinal release as possible. We want high bioavailability of the product as well. So when we're working on new products or improving products, we go through a lot of prototypes. When we find products that have good ruminal stability, good intestinal release, the next step that we look at is feed and mixing stability. I can tell you there's not a lot of this done in the industry. There's not a lot of published research looking at feed and mixing stability with encapsulates, but it's a really key step. If products aren't if they're not stable in feed mixes and TMR, you really are losing the game from the start, because that happens before the cow even eats the product. And I'm going to show you some good examples of that here a little bit later on. So these are, refer to this as the three-legged stool of a good ruminant encapsulate. We really need these three features to be in balance. If one of these is lacking, the product's not going to perform very well. And then ultimately, we need to show biological response in the animal to these products. We want to make sure these products work on the farm. So Reassure XC, I said earlier, our Reassure franchise has been around for 25 years now. We have 41 peer-reviewed publications with our Reassure products. It's one of the most highly researched products in the industry. So we do a lot of research to prove these products actually work in the cow. So there are a lot of different types of testing that can be used to evaluate encapsulated products. The first step really is in vitro techniques. These in vitro techniques are really important for when you're doing product development. Sometimes, we may work through hundreds of different prototypes developing the best product to go to market. And it's really important to have some sort of in vitro techniques to help determine at that point, what products we should go into animal testing with. It would cost many millions of dollars to go straight into animal research without having some idea of what your best prototypes might be. So we do a lot of in vitro testing during the product development phase. Then we go into an in situ step to look at ruminal stability in the cow. And then ultimately, we go into the animal phase and do the in vivo testing of products in animals. So we'll look at the ruminal stability step first. So there are a lot of different in vitro techniques that are out there, a lot of different three-step techniques that are used. Looking, first of all, at the ruminal step, how much of the product's degraded in the rumen, and that's what I'm showing here. The second step would be the abomasal phase, so a low pH step. And then the third step would be looking at intestinal availability. So this is a 3-step procedure. It's known as the multi-step protein evaluation, or MSPE. This procedure was developed by Dr. Mike Van Amberg at Cornell University. We've utilized this technique quite a bit. This works. This MSPE work that I'm showing you, this work was all done at a third-party lab in the United States. This is pretty heavily used in the feed industry in the United States at this point, to look primarily at protein products. So this particular slide is looking at different rumor-protected lysine products that are on the market. So there are 5 different products here, and 3 competitive products. The 2 products on the right are Balchem products. This is our AminoSure L. This is a new prototype that we're developing for lysine. And you can see in this in vitro model, all 5 of these products have pretty good ruminal stability, varying anywhere from 13% ruminal degradation up to 29% for that product. This is some published work. This paper was published in the Journal of Dairy Science in 2016. Some work looking at different rumor-protected lysine products that were on the market at that point. This is in situ data from that published paper. So this is looking at lysine release in situ. And you can see these numbers look quite a bit different from the in vitro data we were just looking at. So if we look at this 6-hour time point, so 6 hours in situ in the rumen of a cow, one of these products is over 90% degraded already. So it's not rumen stable at all. There's another one that's 75% degraded. And, a couple of these products are rumen stable out through 12 hours. But you can see very large differences in situ compared to the in vitro data I was showing you earlier. This is some more of that MSPE data I was showing you earlier. This is on rumor-protected choline products. There are a lot of different competitive products shown here. This is ReaShure XC in the middle. So ReaShure XC has very good ruminal stability. And with this methodology, it was 11%, only 11% degraded in the rumen. You can see some of these products are almost completely released. There's a product there, 100% released in the rumen. There's no reason to encapsulate it. It's not working. And a number of these were over 90%. Degraded in vitro. So there are some really large differences in ruminal stability in rumen-protected choline products. This is in situ data from some of the rumen-protected choline products. So if we were to look at the 8-hour time point here, so this graph is showing rumen stability. So the higher the number, the better in this case. So you can see both ReaShure and ReaShure XC have the best ruminal stability even in situ out of these products. Here's a couple of other competitive products that at 8 hours, they're over 50% degraded in the rumen. Here are a couple of products that are over 70% degraded in the rumen at 8 hours. And here's a product by 8 hours is almost 100% degraded. I think it's the same product that was 100% degraded in vitro. So again, that product's not well encapsulated at all. It's degrading very rapidly in the rumen. The next steps, intestinal release or bioavailability of the nutrient. So this is more of this MSPE data. So in this case, so some of my stuff is not showing up on this graph, unfortunately. There should be 3 colors there. So there's a, so this bluish color is the rumen, that's the ruminal degradation step again. The gray box is, that's the intestinal digestibility step. And then what's not showing up well, there's a 3rd color up there, and that's showing total tract undigested nitrogen. So what we're aiming for in this case is we want a large gray box here. That would be intestinal digestibility in this case. So these are rumen protected methionine products. If we were to look at these different products, there's a huge difference in intestinal bioavailability here. So these products, and I apologize, some of this is not showing up here, but so some of these products are about 80% bioavailable in vitro. There's a product here that's only 30% or only 3% bioavailable. So this product F is only 3% bioavailable. It has a very, very large total tract undigested nitrogen fraction. That's bypass, but it's bypass all the way through the animal, which is not what we want. We just want ruminal bypass. So there's some pretty large differences in vitro with rumen protected methionine products. These are rumen protected lysine products again. The numbers here, which aren't showing up, the in vitro bioavailabilities on lysine are anywhere from about 76% to 40%. This is in vivo research here. So this is our AminoSure-L product. This is data from 2009. So this is measuring in the cow the lysine bioavailability of AminoSure-L. This particular study, the AminoSure-L was 62% bioavailable. For methionine, there are different in vivo methodologies to measure methionine bioavailability. We really like this technique. It's called the selenomethionine technique. Unfortunately, it only works for methionine to do this, but it's an in vivo procedure. You feed the products to the cows. You can even put them through all the feed stability steps as you're doing this. And essentially, the way this technique works, it's a ratio technique. You feed a constant level of selenium yeast to the cows throughout the study. So normal methionine is sulfur containing, right? Methionine has a sulfur in it. When you feed selenium yeast, the selenium yeast, the methionine, actually has a selenium replacing the sulfur. So when you feed selenium yeast, there's some of the methionine that will show up in milk protein, for instance, will be selenomethionine. So this technique's been used a lot in the U.S. It was published back in 2009 by some researchers at Ohio State University, Bill Weiss and Normand St. Pierre. And you feed a constant rate of selenium yeast, and then you feed your rumen protected methionine products, and you can calculate bioavailability as far as how much of that methionine is showing up in the milk protein. That's ultimately what we're trying to produce in the cow. So this was some research done with a competitive product and AminoSure XM. So when these two products were fed at equal methionine levels, they're equal in methionine bioavailability with this technique. That actually matched the in vitro bioavailability I showed you earlier. We fed a 2x dose, a double dose of AminoSure-XM, and twice as much showed up in the milk. It gave us 2 independent readings on the methionine bioavailability of the product. And so the methionine bioavailability with this technique for AminoSure-XM was 54.25%. Another technique that we've been using is stable isotope methodology, and this can be employed for any amino acid. It could be used for choline. It could be used for any nutrient. These stable isotope techniques, in my opinion, this is where we're heading in the future with looking at nutrient bioavailability. Are these stable isotope techniques? This particular research, this was done by a researcher at Virginia Tech in the United States, Dr. Mark Hannigan, and AminoSure-XM had a 55% bioavailability with that technique. So with AminoSure-XM, the in vitro technique, the selenomethionine technique, and stable isotope technique, they actually all yielded the same results for methionine. This is how we characterize AminoSure-XM for nutrition models, and there are a few things I want to point out here. So I talked earlier about how payload can vary. So the methionine content of AminoSure-XM is 70%. So that matters, right? When you're buying a product, you're buying a certain amount of methionine in the product. And then, of course, we're measuring rumen bypass and intestinal availability. So rumen bypass times intestinal availability gives you your methionine bioavailability. So 54.25% methionine bioavailability is how we've modeled the product for the nutrition models. But ultimately, what you're buying in the end is metabolizable nutrients. So the metabolizable methionine content's 38%. That's the number that matters in the end. And it's simply your nutrient payload times the bioavailability of the nutrient. So if I were feeding 10 grams of AminoSure-XM, it would deliver 3.8 grams of metabolizable methionine to the cow. So these metabolizable nutrient values can vary drastically between products. Feed and mixing stability. I said earlier, there's really very little published research looking at feed and mixing stability of encapsulated products. We do a lot of this testing internally. There was a paper published back in 2016. It was done at the Minor Institute in the United States. And that study was done looking at different rumor-protected lysine products that were on the market at the time. So the first studies that we do when we're evaluating encapsulated products, we do mineral mixing of the products. That's a very harsh environment for an encapsulated product. It's essentially like taking sandpaper to an encapsulate. So it's a pretty harsh mixing environment. We do this on a lab scale basis. We do this mixing 45 kilogram batches. We've utilized this technique to look at different rumen-protected choline products, rumen-protected methionine products, lysine products, and even the slow-release urea products. And so we use a pretty basic mineral mix. It's a mixture of sodium bicarbonate, limestone, magnesium oxide, and we put a little bit of soybean oil onto the mineral just for dust control. It's a very dusty mixture. And then we create batches that are anywhere from 41 to 44 kilos of that mineral mix, and then depending upon the product that we're testing, we'll add either 1 to 4.5 kilos of the product to the mix. And then we mix it for 3 minutes. And we test ruminal stability of the product pre and post mixing. So this is a picture of what that lab scale mixer looks like. It's a ribbon paddle mixer. That's what it looks like when it's first loaded. That is not one of our encapsulates. That's not actually a very good encapsulate there, but that would be a competitive product there. So that's before mixing, and then that's after mixing. And these are the results from one of these mineral mixing trials. So this is showing ruminal stability of the products. So the solid lines are the product, ruminal stability of the product before mixing. The dashed lines would be post-mixing. So this work was done with ReAssure. If we look at this 8-hour time point, there's essentially no difference between the mixed and unmixed product. So it has good ruminal stability, and the mineral mixing is not really damaging it in that case. If we were to look at these blue lines, this blue product, that product has very poor ruminal stability to start with. At 8 hours, it's about 80% degraded in the rumen. When we mixed it, it didn't really damage it anymore. There's not much more you could damage it. It's not very rumen stable to start with. So the mineral mixing didn't really hurt that product, but it has very poor ruminal stability to start with. The gray product before mixing was over 60% rumen degraded at 8 hours, but when we mixed that particular product, it only had about 10% ruminal stability after mixing. So that's a good example of a product that's not very mix stable. We lost about 20 percentage units in ruminal stability by mixing that product. So some of these products do not withstand mixing very well. So just general mixing recommendations for encapsulated products. This is true for all products, not just Balchem's products. So when you're mixing a mineral, we suggest 4 minutes or less mixing time. That's pretty standard in the industry. 4 minutes or less mixing time. We want to minimize excessive mixing and abrasion to these products. Ideally, if you can add encapsulated products late in the mixing order, that would help. It would help reduce excessive mixing time. The other thing that makes a very big difference with encapsulated products, if you have a mix that's at least 50% non-mineral ingredients, that really softens the mix, and it really takes away a lot of the abrasion that can occur in a mineral mix. TMR stability. I've only seen one published paper on this. It was this paper that was published in 2016 out of the Minor Institute again, and that was looking at different rumen-protected lysine products. This is some research we've been doing internally. We're utilizing the same methodology that they use at the Minor Institute with one small adjustment to it. This research I'm going to show you will actually be presented at the American Dairy Science Association meetings next month in the United States. So these are different rumen-protected lysine products after exposure to the TMR. And all we're measuring in this case, essentially what we're doing is we take a TMR, total mixed ration, and we add these encapsulates to it. And we let them sit in the TMR, so they're gently mixed, and they sit in the TMR for different periods of time. So we're looking, we take a measurement at time 0, at 6 hours. So 6 hours, if you were feeding cows 4 times a day, these encapsulates may sit in the TMR for 6 hours at a time. We looked at the 12-hour time point if they were being fed twice a day, or at 24 hours if they're only fed once a day. So these products sit in the TMR for the different lengths of time, and we're simply measuring how much of that nutrient, how much of the lysine is actually being lost to the TMR. This has nothing to do with ruminal stability. Some of these encapsulates are losing a significant portion of the nutrient just sitting in the TMR. Again, this is before the cow even eats the product. So there's some pretty big differences here. These are, so if we were to look at, let's look at the 6-hour time point here. There are 2 of these lysine products that are 75% degraded just sitting in the TMR. There are a couple other products that essentially they're very stable in the TMR. They're not losing lysine at 6 hours, and a couple that lose a little bit. If we go out to 12 hours, these products separate even more. This is our new lysine prototype, has very good stability out to 24 hours, and some of these others fall intermediate. The ones that are poor just continue to lose more of the lysine. This is the same methodology, but looking at rumen-protected choline products. This will also be presented at scientific meetings next month. And you can see some pretty dramatic differences here again in the choline products. If we looked at the 6-hour time point, again, there's 2 products that really separate from the others. They're 75 to 80% degraded, just sitting in the TMR at 6 hours. By 24 hours, they're completely degraded in the TMR, in this case. The most stable products actually Reassure XC, that's that line. So Reassure and Reassure XC both have very good TMR stability. So most people don't really think about this, but that's a really important attribute to these encapsulated products. The last part of feed stability I want to touch on very briefly is pellet stability. We've looked a lot at this through the years, mainly with rumen-protected choline products, and we've done some work with the rumen-protected methionine products as well. We do not recommend pelleting encapsulated products. You will do nothing but damage the products if you think about everything that's occurring during the pelleting process. This is some work we've done with different rumen-protected choline products. And if we were to look at ruminal stability of the choline products post-pelleting, almost all of it is being destroyed. So we do not recommend pelleting. So these are the current pelleting recommendations for encapsulated products. This would be true for any product, not just the Balchem products. We do not recommend pelleting any of these products. But I would say our recent pelleting experiments suggest that Balchem's products are just as pellet stable as any other on the market. They're not pellet stable. I would avoid doing this. If you want maximum efficacy of these products, they're not inexpensive products. I would find another way to deliver these to the animal other than through a pellet. They're fine, in mineral mixes or meal feeds. Some people top dress these products or add them straight to the TMR. So we do not recommend pelleting encapsulates. Lastly, biological response in the cow. This is research with AminoSure L. This was some early research done with the product when we first introduced it to the market. So a control treatment versus 30 grams per cow per day or 60 grams per day of AminoSure L. And with both, whether it was 30 or 60 grams per cow per day, we saw an increase in dry matter intake when we added AminoSure L to the diet. And we saw a nice milk yield response, about 2.5 kilos of increased milk yield. And in this particular case, there's no difference between the 30-gram or 60-gram dose. That 30-gram dose of product was meeting the lysine needs of those cows in this experiment. This is a rumen-protected methionine study. These are, in my opinion, very easy to design and show differences. When you feed a rumen-protected DL methionine product, we should see an increase in milk protein percentage. And that's what we observed in this case. We have a control diet, a competitive methionine product, and AminoSure XM. When we added both of these methionine products to the diet, we saw an increase in milk protein percent. This is true milk protein percent. Those numbers may look low to you, but they're about 0.2 of a point lower than a milk crude protein. Dr. Santos showed some of these graphs during his presentation. Again, 41 peer-reviewed publications related to our ReAssure franchise. These top two graphs he showed, this was research published back in 2018 showing the full lactation benefit. This is milk response over the full lactation when feeding ReAssure. Again, the ReAssure in all these studies, we're only feeding the product 21 days pre-partum or 21 days postpartum. There's this carryover effect throughout the lactation. So there is, that's Zenobi right there on that banner. Work done at the University of Florida. The graph on the right was a follow-up study that showed the energy-corrected milk response out through 15 weeks of lactation. The graphs on the bottom are some more recent research done with ReAssure XC at Michigan State University and Dr. Barry Bradford's lab. So our first speaker was showing some slides from Dr. Bradford. That's Dr. Bradford right there, the first person on that banner. We saw very nice milk responses in this case, in this study, over a 3.5 kilo milk response the first 16 days of lactation, and they followed those cows out through 84 days of lactation and a 3.5 kilo milk response. When the ReAssure XC was supplemented just during the transition period again. So these are two very recent studies that were published last year in the Journal of Dairy Science. This is the graph that Dr. Santos was showing earlier from the rumen-protected choline meta-analysis. These are the two newer studies plotted on that same graph. So the green line, that's the milk response in the Barry Bradford trial that I just showed you. The red line is work that was done at University of Wisconsin in Heather White's lab. She's right there. So these cows in that experiment at Wisconsin, the control cows were averaging 55 kilos of energy-corrected milk, very high milk production. Even at that level of production, we still saw a 2 kilo milk response, energy-corrected milk response, when we fed ReAssure XC. So to follow up on what Dr. Santos was saying, choline is required by every transition cow. It doesn't matter what the starting level of milk production is. All these cows are responding to choline supplementation during the transition. So to summarize, when it comes to encapsulated products for dairy cows, there are a lot of differences in these products. They vary by design of the product. Certainly, the payload can vary. The coating types and amounts will vary substantially. There are differences in manufacturing, differences in nutrient payload again, certainly differences in bioavailability of the products, and some pretty vast differences in feed stability. When it comes to ruminant applications for encapsulates, the true encapsulation technologies are what are preferred. in general, they have better ruminal stabilities and better TMR stabilities as well. There are 4 important features of a good ruminant encapsulate. The first one being ruminal stability, the second one being intestinal release or bioavailability, the third one being feed and TMR stability, and then ultimately we have to show the biological benefit in the cow. So, thank you. Samuel, you have any comments now?